Quote, "Science is simply the human race, thinking God's thoughts after him." End quote. This quote by Johannes Kepler describes to us that God is the ultimate inventor, and we discover what he has already invented. I believe this is what the astronomer Kepler was thinking while discovering his 3 laws of planetary motion, which are renowned today. These 3 laws are what we will be discussing in our time together today. Kepler's first law of planetary motion states that planets follow paths or orbits which are shaped like ellipses around the sun. Let's use a diagram to help us understand this. So the sun is at one focus of the ellipse. A planet, whichever planet out of all 8 in our solar system, follows the ellipse in its orbit, meaning that the planet to sun distance is constantly changing as the planet goes around its orbit. For example, let's make a ratio that this planet to sun distance is 4 feet. Now, of course, in reality, it is not 4 feet and much more. However, for the purposes of this video, let's just say it is, to understand it in simpler terms. Over here, it's 10 feet, and here, 3 feet. Let's understand 2 key terms, the aphelion and the perihelion. The aphelion is the farthest away distance. So if the planet is over here, this will be the farthest away distance. However, the planet over here is really close, and that is called the perihelion distance. And that is Kepler's first law of planetary motion. Kepler's second law of planetary motion states that an imaginary line connecting a planet and the sun sweeps out equal areas in equal intervals of time. In other words, planets do not travel with a uniform speed, but move fastest when they are closest to the sun. So, same thing, wherever the planet is, it will be the same, or a different distance, and a different speed. Let's look at this for an example. We have our 2 key terms once again, and over here the aphelion is the slowest, and the perihelion the fastest. So let's take a look at this even closer. Watch this orbit. The planet starts over here for an example, and watch how it goes very slow when it comes to the aphelion. However, you will notice that it starts picking up speed once it gets closer to the perihelion. And then it slows down once again. And then it picks up speed once again. Okay, perfect. And that is Kepler's second law of planetary motion. Kepler's third law of planetary motion states in Kepler's Harmony of the Worlds book, written in 1619, the cube of a planet's distance from the sun divided by the square of its orbital revolution is a constant and is the same for all planets. This is a very confusing statement, so let's dive into it a little bit deeper. The squares of the orbital periods of the planets are directly proportional to the cubes of the semi-major axes in their orbits. Kepler's third law implies that the period for a planet to orbit the sun increases rapidly with the radius of its orbit. Thus, we find that Mercury, the innermost planet, takes only 88 days to orbit the sun. The Earth takes 365 days, which you will notice is our regular year, while Saturn requires 10,759 days to do the same. Though Kepler had not known about gravitation when he came up with his 3 laws, they were instrumental in Isaac Newton deriving his theory of universal gravitation, which explains the unknown force behind Kepler's third law. Kepler and his theories were crucial in the better understanding of our solar system's dynamics and as a springboard to newer theories that more accurately approximate our planetary orbits. These three laws of planetary motion are very crucial to modern astronomers because they are used to predict the movements of planets, moons, asteroids, and as more are discovered, the comets that move through our solar system. These laws also allow us to place satellites into elliptical orbits that can send them far out from the Earth before they return again. Johannes Kepler inspired the world to always remember the true painter of the planets and to reach someday physically for the stars.